All right, so 2.5 is called the fundamental theorem of algebra. It is basically taking what we applied in 2.3, finding roots, linear factors, that kind of stuff, and adding in complex zeros. That's really it, okay? So a complex meaning there's i's involved. The linear factorization theorem says if f of x is a polynomial of degree n, where n is greater than 0, then f of x has precisely n number of roots. So whatever the highest exponent is, that's how many roots there are. That's all that means. If it's an x to the 5th, it's 5. It's x to the 4th. I did say that before, but you haven't officially had a name for it, but we did say that before. The difference is that now those roots can be positive. I mean, they could be rational numbers. They could be irrational numbers like square roots, and they can be imaginary numbers. So they can look like any of these kind. You've got whole numbers in here, you've got fractions in here, you've got square roots in here, and you've got imaginary numbers. Your result can be any of those. So if it said, in this case, there are 1, 2, 3, 4, 5, 6 roots, this would have been an x to the 6th, okay? This is called your linear factorization. So you're going to see instructions for both zeros and linear factorization. This is called linear factors. And then the actual list of all the roots would be your zeros, your roots, your solutions. Okay, they can be written any of those. They all mean the same thing. So sometimes the instruction will say solve and list all the roots, and sometimes it will say list them as linear factors. Linear factors means inside those parentheses followed by x or following x. Notice that even if it's a fraction, there are no fractions in your linear factors. You'll have to do the same thing if you're writing out linear fractions or linear factors, sorry. And the way you get rid of it, like this would have technically been x minus 1/2. You just move the denominator to the front of the x. Okay, if I multiplied both of those by 2, it would cancel from one and multiply to the other. So you literally can just move it there. A linear factor cannot have a fraction, and a linear factor cannot be squared. So these are all linear, meaning to the first power. Kevin, you have a question? Okay. All right, example 1 says find the exact number of zeros. How many zeros are here? 3. That's it. Yeah, I mean, obviously not a test question, but yeah. Yeah. Example 2, now we're solving the function, okay? So if it had said solve before, one of the first thing we would try to do is factor it, but what if it's not factorable? Like, is A factorable?
Yes.
You're all wrong.
What are you talking about?
You're not the only one, though. Why isn't that factorable? It's got to be the difference of 2 squares. That's the sum of 2 squares, okay? So it's not factorable, but if I were to subtract by 36 from both sides, so if this was 0, I'd get x squared equals negative 36, and then I'd square root both sides, putting a plus and minus out front. And what's the square root of negative 36? 6i. Good. So this would be plus 6i. So if I was to separate them out, negative 6i, positive 6i are the zeros. If it wanted it as linear factors, it would be x plus 6i and x minus 6i. So again, zeros or solutions are a list, and linear factors are behind the x in the parentheses.
So we're giving our answer, you want us to write it out like x?
No, this one said solve. You would have given it to this way. If the instruction said write it as a product of linear factors, now you would give the second one. All right, you're welcome. B says x to the 3rd plus 25x. What are we going to do first? I'm actually so happy that that came out. What happens if I divide by x? What happens if you divide by x? What just happened to one of my roots? I got rid of it. How many does there have to be? 3. You cannot divide by x. You cannot get rid of a variable, okay? What you would do instead is factor out the x. So it would be x times x squared plus 25. Now I didn't lose it because now I'd split and solve. It actually was a really good moment because that is an important, people do divide by x, okay? Okay, so I appreciate you doing that for me. Thank you very much. All right, so now on the left-hand side, it's already solved. I get x equals 0. On the right-hand side, I'd say x squared equals negative 25. X would equal plus and minus the square root of negative 25, which is?
Plus or minus 5i.
Good. So my 3 roots would be negative 5i, positive 5i, and 0. All right, now let's say it said, listen. Now let's say it said write it as a product of linear factors. As linear factors, this would be written as x plus 5i, x minus 5i, and x plus or minus 0, it doesn't matter. That would go away. So it would just be x. And it could be at the end or it could be in the front. It doesn't matter. But that's what it would look like if it asked you to rewrite it as a product of linear factors. Good so far? All right, example 3 says find all the zeros of the function, write the polynomial as a product of linear factors. So look at A. Can you factor A? There's no factors of 1 that sum to negative 3, but it is quadratic, which means we can do what? Quadratic formula. So A, don't sound so happy. A is 1. B is negative 3. C is 1. This is a question on your quiz, not those numbers, but quadratic. So negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. Negative 3 just becomes positive 3. Bless you. Plus and minus the square root of 9 minus 4 over 2. 3 plus and minus the square root of 5 over 2. With me so far? Okay, those are my zeros, but it said write them as a product of linear factors. So I have to put x minus in front of each of those. So it would be x minus, I'm going to put it in parentheses so I remember to distribute, 3 minus root 5 over 2, and x minus 3 plus root 5 over 2. Now I need to distribute the minus and I have to get rid of the fraction. So how do I get rid of the over 2? Good. Bring the 2 to the front of the x. So this would be 2x, the minus goes to both here, minus 3 plus root 5. And this is 2x minus 3 minus root 5. That's the product of linear factors. The 2 comes from the bottom. Why do you sound so mad at the 2? The 2 comes from the denominator. In order to get rid of it here, I multiply it. Technically, what I'm doing is multiplying it times both here and here. That's why I'm able to do it. But it's going to cancel from the fraction in the bottom. So really, all you have to do is bring it to the front. And then the minus gets distributed to the numerator that's left. Does that make sense?
So you just move
the denominator to the x. Yep. You're technically multiplying both terms by it, but you don't have to do that whole process.
The negative gets distributed to the numerator.
Yep. Good. Let's say you have all this extra time at the end of the quiz and you really want 100. You could multiply that back out and it should equal your question. Okay? I'm not sure that's going to happen, but hypothetically speaking, yes. If it says write it as a product of linear factors, you could just give it to me in those 2 parentheses like that. Yep. Correct. All right, B. Can I use quadratic formula on this? Why not?
Oh, you could complete the square?
I could, but why can't I use quadratic formula on this? What? How do you know something's quadratic?
There's no b or c.
Good. If it's not x squared, you cannot use quadratic formula. If it's x to the third and there's only 3 terms, it doesn't matter. You can't use quadratic formula. It only works if it's x squared. Okay? This is also the difference of 2 squares, though, so I wouldn't have done it anyways. I would square root both, so 4x squared and 4x squared, and plus 9 and minus 9. Can I keep going? Yeah, with what? Good. So this one gets factored again to 2x plus 3 and 2x minus 3. Can I factor the first one? No, it's not the difference of two squares. So now from here, I'm going to split and solve this. Oh, yeah. You're really loving today.
No, I thought you had to like multiply them all together.
No. If I wanted to check the question, you have to multiply them back out, but you don't have to. All right, so I get negative 3 over 2, positive 3 over 2. And then for the first one, I'm going to subtract 9. I'm going to divide by 4. And I'm going to square root both sides. Not forgetting my plus and minus because there has to be two answers that come into that. What is the square root of negative 9 over 4?
Minus 9i. 3 over 2i.
Good. There's like 4 of you that were right. Good job. 3i over 2, or 3 over 2i. The square root of 9, the square root of 4, and take the I out. So these are my 4 roots. But I have to write it as a product of linear factors. So it's x minus 3i over 2, x plus 3i over 2, x, and I actually can come back up here. This was already in linear factor form. 2x plus 3 and 2x minus 3. Is that it?
Can you also do x plus 3 over 2x minus 3 over 2? Could you do that?
Is that what's there? Oh, the order? Yeah, you could switch up the order. But am I done? Are those linear factors? Is that in the right form? What's wrong? Fraction. So that's going to go to the front. So it should be 2x minus 3i, 2x plus 3i, 2x plus 3, and 2x minus 3. No, order doesn't matter. As long as you get rid of those fractions, the order does not matter. Yeah.
So if you have a fraction, you can just put the denominator behind x.
Yeah, because technically you're multiplying both those terms by the denominator. That's how you're changing it. So you're multiplying the x by that, and you're multiplying the fraction by it, and that's what cancels. It's just faster to just move it. Still good? All right, then comes the paragraph. Find all the possible zeros. That's one thing. Find the actual roots. That's a second thing. Write the polynomial as a product of linear factors. That's a third thing. Use the factorization to determine the x-intercepts. That's a fourth thing. Use a graphing utility to verify the zeros are the only x-intercepts. Okay? You'll do all of this minus that last one on your quiz. So 1, find the possible zeros. How do I find possible zeros? Good. Plus and minus, it's last over first. What's the last term? First of all, make sure it's in order. It is. The last one is 16. Factors of 16 would be? Good. So in order, it would be 1, 2, 4, 8, 16. What's the first? 1. So these are all, they can be left that way, but you got to remember plus and minus, which not everybody did yesterday, sadly. Okay. Wah, wah.
Mr. said you don't need our test back.
Probably tomorrow, hopefully. Yours are graded, but I didn't grade high periods yet. Okay, here's my possible bank, right? Now, how do I find actuals? Think I'm not going to have a calculator, so how do I find actuals? Synthetic division, okay? Yes, so fun. Well, how could I eliminate some? What's the tools we used? Descartes' rule. So if you think about it, if I count as is, 1 sign change, 1 sign change, 1 sign change, 1 sign change. So there are 4 or 2 or 0 positive roots. That doesn't really help me much. But what happens if I make these negatives? Stuff. This is x to the 4th. This is negative times a negative. That's positive 4x to the 3rd. This goes positive, positive 8x squared. This goes positive, and that's positive. How does that help you? There are no negative roots. So as I look at my options, I'm not going to try a single negative one. I'm going to stick to all the positives. Start with 1.
If there's no negative ones and there's also like possibly 0 positives, there has to be a positive one, right? So it can't be no roots.
Say that again?
If there's already like
Right, so it can't be 0. Well, those are real roots. It would all be imaginary if that's the case.
There's gonna be 4, right? Because of the
There has to be 4, but some of them could be imaginary.
Okay.
Yeah. All right, so bring down the 1, 1, -3, 5. Doesn't work. -11, -11. So go to 2. 2, 1, -4, 8, -16, 16. 2, -4, 8, -8, -16. So 2 worked. That's one of our roots. Now take what's left. This would be x to the third minus 2x squared plus 4x minus 8. Good. Put them in groups. Take out an x squared. Take out a positive 4. X minus 2 and x squared plus 4. So I have another 2. So really, 2 is my 0, but why is it important to know that there are 2 of them?
Okay, it's 2 positive.
That's my 2 positive real roots, right? So I have to count those if I'm counting roots, which means the other 2, which are coming from this, would be x squared equals -4. X would equal plus and minus the square root of -4 plus and minus 2i.
Can I discuss that with you tomorrow about-
Sure.
But do those count?
They do. So if you give me the list, you really only need it once. 2, -2i, and positive 2i. But if you give me linear factors, all 4 of them have to be there. So when I write this as a linear product of linear factors, it has to be x minus 2, x minus 2, x minus 2i, or plus 2i, and x minus 2i. So they all 4 of them have to be there. There has to be the same amount of linear factors as there should be roots. What else is it special that 2 occurs twice? The multiplicity. What does that affect? The graph. What's going to happen at the graph if there's a multiplicity of 2? It's going to bounce. What do we think this graph is going to look like? Good. Both arrows are pointing up. And there's only one x-intercept. It would be 2, and it would bounce. So if we graph this, this looks like a parabola because the other roots are zeros, okay? And it doesn't cross through anywhere else other than the 2 where it bounces off. All right. Next up is conjugate pairs. So we talked about this, but all of those imaginary roots come in pairs, right? If I have 2i as a root, I have to have negative 2i as a root. Same is true for an expression. So if I have a conjugate like 2 minus 3i, then its opposite or conjugate also has to be a root. If I had positive 3i, what other root do I know I also have to have? Negative 3i. Good. Any imaginary root of a function would also have its conjugate as a root. So they have to go in pairs. Example 5 says find a polynomial function with real coefficient that has the given zeros. So look at A. It's giving you 3 and 3i. But is that all your zeros? No. 3 and 3 plus I also would have to include 3 minus I. Now I'm giving you the roots and I want the function. So we're going to put these all behind x minus. So this would be x minus 3, x minus 3 plus I, x minus 3 minus I. I'm going to distribute that negative. So I get x minus 3, x minus 3 minus I, x minus 3 plus I. And now I've got to FOIL that out. So I recommend starting with the second and the third because those are the ones that are going to cancel out the i's, okay? If you've done it correctly, then when you multiply by a conjugate, all the i's are going to cancel out. So I'd get x times x x times negative 3, x times I. Then I'd get negative 3 times x, negative 3 times negative 3, negative 3 times I. Then I get negative I times x, negative I times negative 3, and negative I times positive I. And again, if you did it right, the I term should cancel out. Positive ix and negative ix cancel out. Negative 3i, positive 3i cancel out. And what is I squared? This becomes negative 1 minus a negative 1. Good. What comes plus 1? And now combine your like terms. X squared. There are 2 negative 3x's. And then 9 plus 1 is 10. Is that it? No. Why would that be the finished product? Now we get to multiply by what's on the front. Now we FOIL out. X times x squared is x to the third. X times negative 6 is negative 6x squared. X times 10, positive 10x. Negative 3x squared, positive 18x, negative 30. And now combine your like terms. And set it equal to f of x. Questions on that one? All right, we're just going to set up the next one. We're not going to go all the way through. Okay. What other zero should be there? 5 plus 3i. So if I was expanding this, it'd be x plus 2, x minus 5 plus 3i, and x minus 5 minus 3i. And then you would FOIL it out. Again, I would start with the second 2 so that the x's cancel, or the i's cancel, sorry. Do you need me to work through that, or you think you know what you're doing from here? Okay. All right, this is what you should get if you go all the way through and you FOIL it out. So now we take it one step further, okay? And we're going to use a given complex root to find all the roots. So when we did this on your test, you got given a polynomial, and I said something like x equals 2 is one of your answers. And you took 2, you put it on the outside, you reduced it degree, and you factored from there, right? Does that sound familiar? Yes. Now you're going to get given a complex root. So either something with an I or an expression with an I. You're going to, instead of doing synthetic, and you can, so I want to stress that, you can do synthetic with that root on the outside and divide synthetically, except that in your work, you're going to have I's. So it's almost like introducing a variable. So it's possible to do it that way, but then you'd have to use like quadratic to finish it out, okay? The other way to do it is we're going to take our complex zero, we're going to bring in its conjugate because we know it exists, and we're going to multiply those two out, and then we're going to divide the original one by what we just made doing long division, okay? So this is what it looks like. It says use the given zero to find all the zeros of the function. I know, so exciting, right? If 5i is a 0, what's my other 0? Negative 5i. All right, now we're going to make a product of linear factors with those two. So x minus 5i and x plus 5i. We're going to multiply these out. Now you can use a shortcut because those are opposites, which would be a squared minus b squared, but you'd have to keep the I, so be careful. The other option is FOIL it out. X squared plus 5ix minus 5ix minus 25i squared. Middle two cancel out, and I squared becomes negative 1, making this positive 25. So if you remember when we did these with our fractions, the shortcut was a squared plus b squared, same concept, except your b, you don't take the I, okay? You can do that. Now I'm going to divide not synthetically because it's squared. I'm going to divide long division with this guy. 2x to the third plus 3x squared plus 50x plus 75 divided by x squared plus 0x plus 25. So much fun. You have to have the 0x. Why? Good. We skipped that spot, so you have that placeholder. So what goes at the top? 2x. Multiply it out. 2x to the third plus 0x squared plus 25x. Change your signs. 3x squared plus, huh? Yes, thank you. 50. When we multiply it out, it's positive 50x, but then we change the signs and add. Or subtract, same thing. This would be 0x plus 75. And then what do I have to multiply by? What goes at the top? 3, multiply it out. Change your signs. And they cancel. If it doesn't cancel, you did something wrong, because we know these to be factors. So 2x plus 3 is my remaining factor, which makes my remaining root negative 3 over 2. And then all 3 of those are your zeros. So the 5i they gave you, the negative 5i you brought in because it's its conjugate, and then the negative 3 halves you found from dividing. It's not hard. It's annoying, but it's not hard, right? Yeah. We're going to do one more. Yeah.
So every time we see an I, you also do the opposite.
Yep. All right, the last one. So same kind of question, except the expression is given this time instead of a single term. If 5 plus 2i is a 0, what's my other 0? 5 minus 2i. So first thing I got to do is multiply out those linear factors. X, the minus is going to go to both of these. So x minus 5 minus 2i. X minus 5 plus 2i. Notice the only sign that's different is the one on the I term. Then we multiply it out. X squared minus 5x plus 2ix minus 5x plus 25 minus 10i minus 2ix plus 10i minus 4i squared. 2ix, negative 2ix go away. Negative 10i, positive 10i go away. I squared becomes negative 1, and this becomes plus 4. And I get x squared minus 10x plus 29. And then I use that as the divisor into x to the third minus 7x squared minus x plus 87. What do I have to multiply x squared by to get x to the third? X to the third minus 10x squared plus 29x. Change your signs. This cancels. 3x squared minus 30x. Bring down the 87. What do I multiply by? 3. 3x squared minus 30x plus 87. So my last 0 is what? 5 plus 2i, 5 minus 2i, and negative 3. What? I'm sorry.